All right, in this video, we're going to be using Newton's method to approximate our zero. So we can always just take Desmos and plug it in, or a graphing calculator, and it gives us the zero. But with Newton's method, we don't need those two. We can use derivatives and linearization to find that zero, at least an approximation of it. So if we take our function right here, you can see it's graphed. It crosses the x-axis right here, giving us a zero at 3.442. So if we take and pick a point like 3 and we plug that into a function, it will give us an x and y coordinate. What it also gives us is a slope of the tangent line. And so if we take the slope and the slope of the tangent line and the point, we can actually create this line. And you can see that that line intersects right here. So we could find this point, 3.667, because we know that that's 0. And that would give us a new point. And what we're going to do is take that point now and plug it in to our graph. And it'll give us a new point and a slope, which gives us a point that's closer to our 0. And then we'll take and plug that one in. And we get this. And if we keep doing that over and over again, you can see that we now get something that is close to our point, 3.442. And we'll be using a graphing calculator to do this as well. So let's start with the very beginning, just this one point, and let's figure out what's going. So the first thing you're going to do is take your function and take its derivative, because we are going to need the slope of that tangent line. And then we're going to pick some point. This is just a generalized formula now. So we're going to pick x sub 0. And so if we plug that into our function, we get x sub 0, comma f of x sub 0. This is going to be our formula. So that point right there will be x sub 0, f of x sub 0. And then we also know that the slope of this line would then be the derivative at x sub 0. Okay, so what we get is this equation. We get y, remember it's y minus y1 equals m x minus x1. And so if we plug that in, we get y minus, and then our y would be f of x0. Our slope is f prime of x0, and our x sub 1 is x sub 0. Now, I'm going to come back here and call this a and a so that we don't get it all confusing. So we're going to now call this next point x sub 1 right there. And we know that at x sub 1, our y coordinate is 0. So if we plug that in, this x sub 1 and 0 into this equation, what it will do is give us a formula that allows us to find x sub 1. Because we know x sub 0, we know f of x sub 0, and we know the slope. We also know the y coordinate, so the only one's left is him to solve for. So plugging it in, we get 0. Here, let's plug that in with a red. So we're going to plug in 0 and x sub 1. And then we solve. So we do a quick divide, and we get negative f of x sub 0 divided by f prime of x sub 0 equals x sub 1 minus x sub 0. And so again, we're trying to find x sub 1. And we're going to have a formula here that will allow us to repeat this. So we get x sub 1 equals x sub 0 minus f of x sub 0, f prime of x sub 0. And this is our formula to find f of x sub 1. So if we take our point, plug it into the function, plug it in the derivative, simplify it, we get x sub 1. Now, we're going to continue the same thing over and over again like this. So we plug in that point, the slope, and it gives us this point. Now we do it again, and we plug that point in, and its slope, and it gives us this point. And then we plug that point in, and its slope, and it gives us that point. And then keep doing that iteration after iteration, and we get our point. So this took 5 iterations to get there. You can see at the 4th, it's close, but not quite as good as the 5th. So we're starting. So you can think of this formula as the same thing. To find x sub 2, it would be x sub 1 minus f of x sub 1, f prime of x sub 1, and then so on. So x3, we'd be plugging in x2, and to find x4, you're plugging in x3. So we get this formula. You can see n plus 1. So what we're going to do is use our calculator now to calculate that. So this formula here is what we're going to use to find each new x value. And so again, we're going to use one iteration. It'll give us that point. The second iteration will give us this point. The third iteration will then give us that point. The fourth, and then finally the fifth. So it's going to keep going in. So what we're using is those 3 points, that point and the slope, sorry, to get that point, and then that point and its slope to get that point, and then that point and its slope to get that point, and so on, and so on, and so on. So we're going to plug y1 and y2 into our calculators. So plugging them in our calculator, we get this. We get y1 is this, and y2 is this. And I've already plugged them in because me plugging it in with a mouse is going to be a lot slower than you will. So hit pause, plug them in your calculator, and when you're ready, unpause, and we'll continue. All right, now you're going to hit second quit to get out of that, and we move on to the next one. So we're going to need an initial guess. We're going to plug in x equals 3. So to do that, we're going to hit 3, stow, x, and enter. So like this, 3, stow, we're going to stow in an x, and you hit enter. So what that means now is x has a value of 3. So that's our first guess. So that is our x sub 0. That's what we are creating here. This is our x sub 0. Now what we need to do is enter this formula. So to enter that formula, we're going to replace the f of x with y sub 1 and f prime with y sub 2. And then we're going to create our formula for that. So this will be x, take away, and then y sub 1, y sub 2, stow in x. So it's going to take, our x has already been given, it's going to plug into each of those. So we select x, take away, and then if you go to vars, y vars, and function, that's where you'll find your y sub 1. And then we're going to divide that by y, and then y sub 2. And then you're going to hit stow, and you're going to put x. So what this is doing is taking our x of 3, plugging it in, and it's going to give us a new value of x. So when I hit enter, we get 3.667. And so that's our x sub 1, which would then make that our x sub 2, our x sub 3, our x sub 4, our x sub 5, and our x sub 6. So all you have to do is just keep hitting enter now. So your x, vars, y vars, there's your y sub 1, vars, y vars, select number 2. Actually, it is 1. And then y2, and then you stow x in there. So now if we hit enter, watch what happens. Enter, 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 enter. And if you just keep looking, you can see it's the same value. So that is as accurate as we're going to get. Just keep hitting enter until you get the same thing over and over again. So that is our 0. And you can see it's here. It was the 5th iteration that gave us that approximation. So that is all you have to do. So we plug in 3, it gives us 3.67. We do it again, and it gives us 3.471. We do it again, it gave us another 3.471, but even closer, 4th, and then finally 5th gave us what we needed for this problem. Now, you do have to be careful. There are restrictions. So remember that denominator in our formula is right here. It's our derivative. So in our derivative 0, this is not going to work. So if you look at our graph of their derivative, that's the red one, you can see that at 2, we're getting 0. That's undefined. So now if I were to try and start with 2 to find this point, watch what happens. It doesn't work. So you do have to play with these. And sometimes also just getting closer and closer to 2, you can see here how far off it is. So we were at 3, right? So as we get closer to 3, you can see they are all converging right there on that point. But as we go away and our slope gets more and more horizontal, it's not working very well. I mean, it's gotten pretty close here, but we're going to have to do a lot more iterations because we're too far away. So sometimes you just have to play with them. Look at the graphs as well. But the more horizontal you make your slope, your first guess is, they're going to go away. The worse it's going to be for you. So you've got to make sure that you're picking a point close enough that it works. So if we had started with 2.6, 2.7, any of those, we would have been good. 3, all of those look good. See how they're all converging in that point. But anything closer to 2 wouldn't have worked. And there you go. So it's a pretty cool little thing. It does converge fairly quickly if you pick the right point, but it's all based on just linearizing I'm kicking a line and its point of intersection, and then just completing that over and over and over again. Thank you.